Hi and welcome to the Triangles and Transformations review video. This is Miss Guida. Make sure you remember to pause and rewatch any parts of the video that you need to until you feel confident with the material. Turn this in tomorrow. No late reviews or incomplete reviews will be accepted. Number 1 says, solve for x in the following triangle. What you're going to notice is that each of those expressions is in an angle, and you need to remember that all of the angles in a triangle should add up to 180. So we're going to start by making an equation that says that. We know that 9x minus 16 plus 7x minus 5 plus 3x plus 11 should all add up to 180. Combine your like terms. 9x plus 7x plus 3x will add up to 19x. Combining all the numbers, we get a minus 10 equals 180. We're going to solve by adding 10 to both sides. 19x should be 190. And finally, you divide each side by 19. X equals 10. That's all we needed to solve for in this problem, but if we needed to figure out the measures of the angles, you'd go back and plug 10 into each one of those expressions. Number 2 says solve for all of the missing angles in the triangle below. The most important thing to realize in this problem is that we have a pair of parallel lines. Put them in red in this problem. And note that we also have a transversal. So think back to our parallel lines and transversals problem. If this top angle was 38, angle 3 will also be 38 degrees because those guys are alternate interior angles. So I'm going to write down that angle 3 is equal to 38 degrees because they were alternate interior angles. Now I'm going to go back to this picture and see what else I know. In this bottom left-hand corner, we've got a 90-degree angle. Note that I'm putting that in my picture. And here on the left, we have a triangle, which I just outlined in blue. So since it's a triangle, I know that 90 plus 38 plus angle 1, I'm going to call it x, should all add up to 180. When we go ahead and solve that, we get x ends up being 52 degrees. And that's going to be the measure of angle 1. So angle 1 over here in our picture would be 52 degrees. We know angle 3 was 38. So on this top triangle, all of those will also add up to 180 degrees. So similarly, 38 plus 63 plus angle 2, which I'll call y, should equal 180 degrees. If I go ahead and solve that equation for y ends up being 79 degrees, which was angle 2. So in this problem, we ended up using parallel lines, and we use the fact that triangles add up to 180 degrees. Question 3 says solve for x in the following triangle. Notice this triangle already has some markings on it. I know that these two sides with the marks are equal. And if two sides are equal, we know that this is an isosceles triangle. If it's an isosceles triangle, we also know that the angles across from them will be equal. So I know that both of those corner angles, those top angles, are equal. So if the top left one is 9x plus 1, the top right one will also be 9x plus 1. Now that I have every angle in this picture labeled, I know that all of them should add up to 180. So I know that 9x plus 1 plus another 9x plus 1 plus 88 equals 180 degrees. When I combine my like terms, 18x plus 90 should give us 180. 18x equals 90. So x ends up equaling 5. Remember, as before, this problem only asks us to solve for x, But if we wanted to find the measure of the angles, we could go back and plug them in. Question number 4 says find the values of x and y. Notice there's 2 expressions that have x's in it. So that's probably where we're going to need to start. We have an x here and an x in this exterior angle. That makes it necessary to remember our exterior angle theorem. We know that this 9x plus 4 is equal to the sum of our remote interiors. That's that 4x minus 7 and the 86. When we go ahead and combine those like terms, we get that 9x plus 4 is equal to 4x plus 79. Let's get our x's on one side, numbers on the other. So we know that 5x plus 4 equals 79. Subtracting 4, 5x is equal to 75, and x ends up equaling 15. There's a couple ways we could figure this next part out, but I'm going to use the fact that these 2 angles, the exterior and the one next to it, form a linear pair. That means they are both going to add up to 180 degrees. We know that x is 15, so if I plug it into the 9x plus 4, that is 9 times 15 plus 4, which is 139 degrees. So now I know that 7y minus 1 plus 139 equals 180 because it's a linear pair. 7y plus 138 equals 180. So 7y is equal to 42. Dividing both sides by 7, y equals 6. Number 5 asks, which of the following could represent the side lengths of a triangle? Check all that apply. That means we have to check each and every one of these. If 3 numbers are going to form the sides of a triangle, we know that our small side plus our medium side must be strictly greater than the large side. So in this first one, we want to add 11 plus 17. That's going to be bigger than 19, so that's a correct answer. I'm going to shade that in. In the next one, if I add my small and my medium side, they do not equal something bigger than 52, so the middle one's out. When I add 9 and 25 in this next example, it equals 34, and that's not what we want, so that one's out. And the last one, if we added 13 and 14, that's going to give us 27, which is bigger than 22. So that's a correct answer as well. Number 6, which of the following lists the sides of DEF in order from shortest to longest? The first thing you're going to notice is that we're missing what angle D is. So I know that all 3 angles should add up to 180. So if you do 180 minus 54 minus another 58, that's going to leave us with 68 degrees. Put your 60 inside your triangle. The shortest side of our triangle is always across from the smallest angle. So the shortest side is going to be DF. The only answer choice to start with DF is answer choice D. But let's keep going and make sure the rest of this works out. The medium angle is 58, so the medium side would have been DE. And the biggest angle is 68, so the side across that is EF. So answer choice D. Make sure if it's not a multiple choice question, if it says sides, you list sides. If it asks for angles, you list your angles. Number 7 says 2 sides of a triangle measure 17 and 9 inches, which cannot be the length of the remaining side. Key word is the one that doesn't work. Anytime they're giving us these 2 numbers, we're going to make our inequality with an x in the middle and 2 less than signs. To get the first number, we're going to subtract them. 17 minus 9 is going to give us 8. And I'm going to also add them. 17 plus 9 gives us 26. We want the number that's not in between 8 and 26, which is going to be B, 26. Remember, those are strictly less than signs. If triangle WXY is an equilateral triangle and WZY is isosceles, find each missing angle. Note that you don't necessarily need to find each one of these in order. If it's an equilateral triangle, I know that all of the angles are going to equal 60. So I do know that angle 1 is 60. 2 and 3 together would give us 60, as well as 4 and 5 together would also equal 60. So in my answers, I'm going to fill out that angle 1 is 60 degrees. I'm not sure, based on the rest of that, what any of the other angles are until I read that WZY is isosceles. So I know that these two side lengths are going to be equal. If WZ and ZY are congruent, then angles 3 and 5 will be equal. So let's figure them out. A triangle is 180 degrees. We've used up 138. That's going to leave me with 42 between the two of them. Divide that by 2, we know that each one of those angles is 21 degrees. So angle 3 is 21 degrees, and angle 5 is 21 degrees. Final step is to figure out what 2 and 4 are. Well, I know the whole angle, let's look at y. That whole angle is 60. And I've already used up 21 with angle 5. That's going to leave me with 39 degrees left over for angle 4. And it's also going to leave me with 39 degrees left over for angle 2. Describe the type of symmetry the following figure has. And I'm just going to go down each one of them. Line symmetry. I can draw a line of symmetry through this shape. If I draw one vertical line and I folded it over itself, it would lie flat on top of itself. So it does have line symmetry. Point symmetry means if I flip this shape upside down, will it look exactly the same if I rotated it 180 degrees? Well, that wouldn't look the same because then the arrow would be pointing down. So it doesn't have point symmetry. And rotational symmetry wants to know if I can rotate it any number of degrees. I can't unless it's 360 and it goes all the way around. Same question here. Does it have any line symmetry? Well, yes, we can draw lines through it. We can draw a vertical line. We can draw a horizontal line. We can draw a couple of diagonal lines through these points. So it definitely does have line symmetry. Point symmetry. Can we flip this thing 180 degrees and will it look like itself? In this picture, all of the points would line up if we flipped it 180 degrees. So I'm going to say yes. And rotational symmetry. If I start rotating this piece by piece by piece all the way around, this can make several stops and still lie flat on top of each other. We would have stopped 1, 2, 3, 4, 5, 6 times. So that would be a total of 360 degrees divided by 6 would have given us 60-degree rotational symmetry. Number 11 asks us to reflect each point over the x-axis. Plot them on the graph, and write their new coordinates. Remember, if we're reflecting something over the x-axis, the x is going to stay the same, the y is going to be negated. You don't necessarily need to memorize those rules. You can think about them as you flip it. So if I'm going to take point A and flip it over the x-axis, it's going to land below the x-axis here. That'll be called A prime. Its coordinates are going to be -1, -1. B was up here at 3, 0, so now it's going to be, or 0, 3, I'm sorry. So B is now going to be down here, at B prime, at 0, -3. And finally, see we had the coordinates 3, 1, 2, 3, 4, up 4. We're going to stay at the 3 and this time go down 4. This will be C prime. It's going to be at 3, negative 4. And finally, number 12. Translate point A, so just one point, using a translation of xy translate to x plus 3, y minus 2. Name it A prime. So let's do that first. Plus 3 in the x direction is going to be a right 3, and y minusing 2 is going to be down 2. So let's take A and go 1, 2, 3, down 2, and put a dot, and we'll call that A prime. Then we want to reflect it over the line x equals 4. That's going to be a vertical line going through the point x equals 4. Drawing that on blue on our graph. And now we want to reflect it over that blue line. Well, guys, we were 1, 2 to the left of that line x equals 4. So now I want to go to the right of that line x equals 4 and put a dot. And this one we're going to call A double prime.